So the next chunk of this course, which will be the subject of the next 4 or 5 videos, is this notion of hypothesis testing. This is one of the most important applications of statistics, and you can think of it as ways of validating a certain hypothesis that you may have about the world. Okay, so let's take like a few like common famous type kind of examples. So like perhaps the most famous example of the lot is things like smoking. Does smoking cause cancer? Okay, and there's things that have been addressed in XKCD comics like do jelly beans cause acne and things like this. So you should see the link that I posted on Piazza. It's actually a very funny read. It explains the it explains the comic as well. Okay, and there's the more recent example which you probably saw in the news, which is does air pollution correlate with occurrences of COVID-19? Right, so you see these kind of hypothesis testing based results everywhere in the news, and this is the most common form of statistical inference. Okay, so before we get there, one important fact that you should remember is that statistical methods and all the kind of things that we are going to talk about cannot really tell us about causality. Like suppose I mean like the way I phrase this question is as saying, does smoking cause cancer? Right, so statistical methods really cannot tell us about whether it actually caused cancer, or maybe there were common underlying causes for the two, things like this, right? So all it can tell us is that there is a significant correlation. Okay, what is significant is will be the subject of this whole hypothesis testing. Okay, but they only tell us about like significant correlations between these things, right? And right, and this is the same with this air pollution causing COVID-19 kind of studies. So all you can be sure of is whether there is like a statistically significant correlation between air pollution levels and occurrences or deaths due to COVID-19. Right, so that's the so that's one thing to always keep in mind when you are thinking about hypothesis testing. Okay. Like for instance, if you take this example, the last example, right? So you can imagine that the same factors that cause pollution also cause spreading of viruses, right? Like if you're in like a populated city where there's a lot of interaction, lots of movement, lots of stuff going on, that obviously is the source of pollution, human activity and industries and things like this. But that's also how viruses tend to spread, right? So it's really no surprise that that's there. Okay, and another explanation which is also intuitive is somehow that all respiratory diseases are linked to pollution. That's somehow true, and this is this is an example of a respiratory disease. So that's another explanation, right? So it does not tell you that air pollution directly causes this an increase in these levels, but maybe the same factors. So but you can still establish significant correlation, right? Okay, so that'll be the topic of the next few lectures. That's called hypothesis testing. Okay, so let me start with a story about how this whole field originated. Okay, so this is Ronald Fisher, and he wrote this highly influential paper in the early 1900s, which is called The Design of Experiments. Okay, and it's one of the most famous papers in statistics. He kind of started out this whole field of hypothesis testing. Okay, and he introduces it with like an anecdote, which is about him attending a tea party. Okay, so I mean he was British, so he went to a party, and there was apparently a lady who claimed that tea should be made, good tea at least, should be made by first brewing the tea leaves, and then adding milk, and not vice versa. Okay, And of course, and she claimed that she could taste the difference. She could taste the tea and tell if it was made using method 1 or method 2, right? As you can imagine, most such claims are kind of suspect, right? People say that they can do that they can tell apart between like things like this, Coke, Pepsi, stuff like that, but we are not 100% sure. Okay, so what Ronald Fisher decided to do is do a test where he told the lady that I'm going to give you 4 cups with method 1, which is brew tea, then add milk, and 4 cups made by method 2, which is first pour milk and then add tea. Okay, so I assume this just means add a tea bag or something like that. Okay, so that's not very significant. Okay, so the point is, the point is that the lady knows that 4 cups are made with method 1 and 4 cups are made with method 2. Okay? So now the question is, suppose you ask the lady to take guesses, and you ask and you find some outcomes, right? So let's say out of the 4 cups, so let's call these type A cups, type B cups, not to be confused with something else that's going to come, but for now, right? So then, so maybe she got out of A, maybe she got 2 out of 4 correct, and maybe out of B she got 3 out of 4 correct, or something like that, right? So, okay, so now you can ask, okay, so maybe the one way of viewing this result is by saying that, okay, maybe there's some signal here, right? Because she seemed to get more correct than incorrect, right? But if you think about it, you can say that, okay, even if I guessed, there's a decent chance that I would be a little bit better than correct, right? Because it's a binary choice. If you had to make a binary choice completely by accident, by at random, you might. I mean, if I toss 4 coins and ask you to predict the outcomes, the probability of getting 3 of them right, it's maybe not too great, but it's not negligible either. Okay, so that's the sort of a thing, computation, that is at the core of hypothesis testing. Okay, so the question, so the way you formalize this is as follows. Okay, so you formulate what is called the null hypothesis. Okay, so the null hypothesis is a pessimistic worldview. Okay, typically. Okay, so the null hypothesis in this example would say lady has no special powers, special ability, she is guessing. Right? Okay, so that's like the null hypothesis. And the alternate hypothesis is the negation of this, at least in the current setting I'm going to talk about. Is no, lady has some has an ability to tell the difference. Okay. And the key idea that Fisher proposed is this notion that key idea behind hypothesis testing is to say is to compute the probability of the experimental outcome under the null hypothesis. And so what does that mean in this case, right? So suppose the lady ended up with, so you have 8 answers total, and maybe she ended up with like 6 correct answers. Now you can ask, okay, so if she was randomly guessing, what is the probability that she got 6 out of those 8 being correct? Okay, and this is where the main thing comes up. So if the probability is lower than some threshold, okay, then you reject the null hypothesis. Okay, so this is the main idea here, right? Which is that if your probability of of having these experimental outcomes, okay, so the way you go about this is as follows. First you formulate the null hypothesis, then you formulate the alternate hypothesis, which is the opposite of the null, and now you conduct the experiment. Okay, so that's the order in which you have to do things. Okay, now you conduct this the experiment, and you end up with some data. Okay, so let's say you end up with like 6 correct answers. Okay, and if the probability of this experimental outcome, assuming the null hypothesis, is very very small, okay, so let's say in our example that somehow the lady got all 8 correct. Okay, now intuitively you might guess that, if she was guessing randomly, it is of course possible that she gets all 8 correct, but the probability of that is very low. Okay, what is more likely is that somehow she had some signal, right? So that's the idea here. So you set a probability threshold, right? So you say that, okay, the probability of getting all 8 correct was maybe, I don't know, we'll compute the exact probability in the next video, but let's suppose that it is something like 1 over 100. Okay. So then this, based on your application, this might still be might be considered like a high probability, right? But for most cases, 1 out of 100 chance is quite low, right? So in fact, in most of his things, Fisher set the probability threshold as 0.05, and in a lot of scientific papers, 0.05 is accepted as like a valid threshold to discover if to see if you have a non-trivial, I mean, if you've actually discovered something interesting or not. Okay, so right, so if you find that the probability of getting these experimental answers under the null hypothesis is too small, then you decide that, oh, okay, it's unlikely that that the null hypothesis held, right? Like the lady was getting all 8 things correct, and that would have been extremely unlikely if she was just randomly guessing. Okay, so that's the idea behind hypothesis testing. Okay, that you formulate the null and the alternate hypothesis, and if your probability is lower than a certain threshold that you fix, okay, then you reject the null hypothesis. Otherwise, you say that there is insufficient evidence. Declare insufficient evidence to reject the null hypothesis. Okay. Okay, so we'll see an exact calculation of this example in the next video.